We humans live on the planet Earth, and it may seem like the biggest thing ever existed. However, Earth is part of a galaxy called the Milky Way. There are about 100 billion galaxies in the universe, and the Milky Way, which the Earth is located in, is just one of them. Every star we see with our naked eyes is in the Milky Way galaxy. The Milky Way galaxy consists a solar system with the components of the Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. First, to start off with the mother of our solar system, the Sun. The Sun is a star, but at the same time is the largest object within our solar system, comprising 99.8% of the system's mass. This goes to show that our stereotype about stars being smaller than planets is not always true. The Sun is located at the center of our solar system, and Earth, the planet where we live in, orbits 93 million miles away from it. And it is the Sun's magnetic field that spreads out through the solar system via solar wind and keeps all of the planets in a certain cycle. Did you know that one day the mother of the solar system, the Sun, would cover Earth with her flames? The Sun will continue to burn for about 130 million years after it burns through all of its hydrogen, instead burning helium. During this time, it'll expand to such a size that it'll engulf Mercury, Venus, and Earth. When it reaches this point, it'll become a red giant star. And after it has burned all of its helium and the Sun has completed its red giant phase, it'll start to collapse and its huge mass will be retained into the size of Earth. It would be known as a white dwarf. Mercury is the first planet I'm going to introduce to you, part of the solar system which Earth is located in. First, Mercury is the smallest planet on the solar system and also at the same time is the closest to the Sun. And its day or rotation is 59 Earth days, and its revolution around the Sun is 88 Earth days. So 2 days is longer than a year for Mercury. Mercury has no moons and no rings, and has a very rocky surface and has a thin atmosphere. The thin atmosphere makes it almost impossible for living creatures to live in. The planet I'm about to introduce to you guys is Venus. Venus is a planet that has the similar size to the Earth and is the second closest to the Sun. While its day is 243 Earth days, in contrast, its year is 225 Earth days. Its day is longer than a year, which means its rotation is longer than its revolution. And it also has no moons and no rings, and it has a thick atmosphere filled with carbon dioxide and yellow clouds of sulfuric acid and trapped heat. This makes it almost impossible for living creatures to survive in the planet. It is also the first planet to ever be explored, and Venus has a solid surface. It has a volcanic landscape covered with extensive plains, featuring high volcanic mountains and vast ridged plateaus. The next planet I will introduce to you is the planet of life, planet where we live in, Earth. Earth has a similar size with the Venus and is the third closest to the Sun, receiving just enough sunlight for every creature to enjoy the vitamin D from the giant star. Its day is 24 hours, but many people know the year as just 365 days. But in fact, it's 365.25, or to get more specific, 365.2422 days. So the extra 0.25 days is what creates the leap years within our Earth years. Because 0.25 days is stacked 4 times every 4 years, 0.25 times 4 is 1, another day is added every 4 years. That creates the 366 leap years. This may seem exact, precise, and perfect. However, this calculation has some flaws. According to a research by NASA called How Many Days Are in a Year by Evan M. Manning, a day is not actually 365.25 days. It's 365.2422 days. So we are a little off, to be precise, about 0.0078 days off every time. And 0.0078 days equals to 11 minutes, 11.232 minutes. So every year we're getting 11.232 days ahead of the actual time we're going. So if you look at this report again by Evan M. Manning, there's a report and a calculation. And for the calendar to be more precise than the Gregorian calendar, it is reasonable to skip one leap year every 128 years. This is a way to make things simple but actually accurate. At least in my opinion, I think this research or this report paper has a huge significance because humans' life or humans' day revolve around time, revolves around the clock we have there. But if it's 11 minutes delayed every year, one day our morning would be night and night would be morning with just simply skipping with every leap year we get. This report has a huge significance. Humans' day is revolved around time. Everyone has a schedule, and just by having 11 minutes off every year, our schedule would be ruined. Maybe our schedule could be simple as I sleep at 11, I wake up at 6, and I exercise for 30 minutes, and I eat my breakfast, and then I go to school, something like that. However, just by having an inaccurate year, everything would be ruined. And our morning would be night one day, and our night would be morning one day, ironically. This would create a huge negative impact to society, as a lot of other things, and not even just human day, is revolved around the time we are using right now. I think it is a problem, and to give a solution, I think it's just simply better to maybe even just change the day we have, change the hour we have, instead of just going for 24, just like a perfect number. Or just simply having Evan's idea of skipping a leap year every 128 years would be okay, but that's still a problem because that's still not a perfect calculation. So I believe a perfect calculation would be needed for us to have a perfect schedule. The next planet I want to introduce to you guys is Mars. Mars is a very mediocre place on terms of size. If the sun is a door, the Earth is a dime, and Mars is an aspirin tablet. It is the fourth closest planet to the sun and also has the biggest possibility for life besides Earth, mainly because it has similar environment with the Earth. Its days 24 Earth days, while its years 687 Earth days. Solid surface has been alterated by volcanoes, impacts, winds, and crustal movement, as well as chemical reactions. An atmosphere is similar with Earth. It's mostly made of carbon dioxide, argon, nitrogen, and a small amount of oxygen and water vapor. This is an important part. Two moons, Phobos and Deimos, and it also has rust and soil, as soil contains some minerals that could actually rust or merge with oxygen. So this proves that there's enough oxygen for the some metals and minerals to actually mix with oxygen so that they will decay. Mars is also the planet that is most explored besides, of course, Earth. The reason why we explore these places to find new minerals and new resources, and Mars may just have the biggest resource we could ever find. It has a place where we can actually live and populate. There is possible water, flowing water on Mars, as there's water vapor in the atmosphere, and there is a huge possibility that there are living things or living creatures within the planet already. Mars is one of the planets with the biggest developmental potential. However, as always, it is not easy to explore something outside of Earth. It's in space. It's not easy. They cannot control their spaceships and rockets on space perfectly. So they have to make perfect timing to fit the orbit. When a spaceship leaves the Earth, it spins on a somewhat semicircle orbit around the sun. And it is important that that semicircle one day from Earth starting, it had reached Mars, and after Mars, it had reached the Earth again, without bumping into other planets, of course. Therefore, it is important to measure when will the spaceship be able to visit Mars and then come back to Earth. This is an actual simulation of when the next space travel would be. It would be in 2022, about December 31. Though in the simulation, it said that experiment has failed and the spaceship has crashed, it would be most reasonable to actually think that it would be somewhere near December 31 of 2022 where a spaceship would travel for Mars. Because if you look at the video I just showed you, so it would be near that day when a spaceship would travel for Mars. The next planet I'm about to introduce to you is Jupiter, which is known as the biggest planet and the fifth closest to the Sun at the same time. Its day is 10 Earth days while its year is 10 Earth years. So the ratio between a day and a year is the same with Earth. And it has more than 75 moons and has a few faint rings. Jupiter's red spot in the middle is a storm that has been going on for more than a century. And Jupiter is made up mostly of hydrogen and helium, making a gas planet without any solid part to actually step on. The next planet I will introduce to you is Saturn. Did you know that 9 Earths could fit in the diameter of Saturn? And even without the rings. It is also the sixth planet from the Sun, and its day is 10.7 Earth days, and its year is 29 Earth years. It is also a gas planet, just like the previous planet I introduced to you guys, Jupiter. Saturn's atmosphere is mostly made of hydrogen and helium, and has 82 moons and 7 rings. Every 29 and a half a year, the Saturn appears ringless because all of the rings line up in a single line in an angle where it is not visible in Earth. The next planet, or the second last planet I'll introduce to you, is Uranus. If Earth is an apple, Uranus is the size of a basketball. Its day is 17 Earth hours and its year is 84 Earth years. It is the seventh planet from the Sun and has 27 moons with 13 rings. And unlike the previous planets, Jupiter and Saturn, most of its mass is really hot. But it's created with icy materials such as water, methane, and ammonia. Atmosphere also mostly made of, again, hydrogen and atomic helium, very common for the planets farther from the Sun. And it cannot support life at all. Finally, the last planet that will wrap up my video about the solar system focused on the planets and the Sun will be Neptune. The Neptune is similar size to Uranus and it is the farthest planet from the Sun. Its day is 16 Earth hours, and because it is the farthest planet from the Sun, it has a terribly long year. 165 Earth years serves as 1 year in Neptune. And there are 14 moons known and 5 rings. And most of its mass is hot, but again made of icy materials. It is similar with Uranus.